All good evening to all of you. Then we will start the second session of this course, that is problem solving using NumPy and MatplotLib. So we will be having two case studies for this approach. First, we will try to solve linear algebra, and as a second case, we will be taking least square curve fitting. Okay, so how to solve these kinds of problem using the Python programming language. Okay, yesterday we have seen one external library called OGR. Okay, we were able to import that OGR into our Python environment, and after importing, we were able to open some save file and extract some information from that save file. There are some further lessons also, further classes will be there where you will be doing more geoprocessing kind of thing. So before proceeding to the geoprocessing, pure geoprocessing kind of thing, we will having one hands-on on this NumPy and MatplotLib also. They are the two very important Python libraries used in many business problems or geospatial problems also. We can utilize these libraries for solving all those things. Like array processing is there. If I want to plot some graphs, so these two are the libraries which handles those array processing and graphs. And we will try to link how this array processing and graph plotting is useful for our geoprocessing. So this lecture will be a hands-on kind of thing for you for learning advanced topics of geoprocessing. Okay, so we will be having these two cases, linear solving some linear equations and having the least square curve fitting. Okay, so this we will start with it. So the content of this lecture is arrays and matrices. They are the very important data types, we can say. So second, we will be taking matrix operations like multiplication, transpose, identity, inverse. These are some of the operations of matrix which will be we will try to handle with the help of Python. Okay, and more specifically with the help of NumPy. Then we will be talking on least square fitting. Okay, suppose I have a set of values are there and I want to fit a linear or I want to fit a straight line onto it. A set of observations are there, x and y. I have n numbers of x and y observations are there, and I want to fit a straight line or any kind of curve it can be. So here we will take how to fit a straight line curve on a set of observations. How to solve this problem, how to get the results from this programming kind of thing for this sort of problems. Okay. Second, once that line is that equation is fit, like straight line fit, there are other advanced options also, like I can fit a quadratic equation also. I can fit some polynomial equations also to a set of observations. As an first we have to analyze all the observations by plotting a scatter plot. Once you see the scatter plot, you will be observing whether the data is a linear trend or it is or it is something there is no correlation between them, or it is following some curvature kind of thing. So accordingly, we can fit the curve on that data sets. So we will take one example of linear line fit, your straight line fit. Okay. Then we will be having some small curve fitting also, curve plotting also. Okay. How to plot some data sets using Python programming language. So to start with, so what is NumPy? The first topic, if I say, it stands for numerical Python, and it is a Python library for handling multi-dimensional array and collection of routines and processing for those arrays. So this is one module which is capable of handling arrays. Like one example we will take, where do we use arrays? Whenever we are doing image processing, image is nothing but image is a array. It is an array of pixel values or DN numbers. So to handle that image, so image is one live example of an array. So this NumPy is the module or the library that is inbuilt into Python, which help us to handle those arrays. Now there are n number of processes that we can apply on top of an array. Like yesterday we were seeing in geoprocessing, I can do focal operations, local operations, zonal, global. I can do the array multiplication, array addition, subtraction, all arithmetic operations. So whatever processes are there, so instead of writing those code from scratch, this NumPy module gives me the method which it takes the input as an array and it does those operations on those arrays. So we will see how to do that one, like addition of two matrix I want to do, or addition of two arrays I want to do. So how to do that one? Yeah, transpose of an array I want to find out, or a matrix I want to find out. So that becomes very easy because all the modules have been readily inbuilt into it. We will see one example for it. Okay, so now using NumPy, mathematical and logical operations of array can be performed. Any kind of mathematical or logical arrays that can be performed on top of a array. Second, if we say, now this is the very basic data type for NumPy. It is named by ND array. It is the most important object defined in NumPy, and n-dimensional type, it is called ND array. It describes the collection of items of same types. Important point is to be noted over here is that all the elements are of same type. If I am saying image, then all I should have digital numbers only. Then array should not be a collection of string or numbers. It should be of same type, either all of numbers or all strings. Okay, so this is one important point with this ND arrays or with the NumPy. So because we have another type of array in Python that is called list. In list, I can mix numbers as well as strings. But if I want to do specifically array processing, then I will make use of ND arrays or the NumPy arrays. Okay, but the thing is that this array should contain only same type of data. Either it should be all integers or it should be all floating point numbers. Okay. Now item in the collection can be accessed using a zero based index. Means if I am saying an array, so the first element of the array will be called as 0th element. The element at 0th place. So the indexing or the numbering of that array will start from 0. So if I say my array has 100 numbers or 100 items are there, then the numbering will be from 0 to 99. Okay. So the important point to be noted is that this indexing, it starts from 0. Okay, the first element is 0 only. Now the basic ND array is created an array function in NumPy as follows. It is very simple, like I can create it like numpy.array. Simply I will write it and it will create one array for me. We will see one example of it. You see this example here. So first of all, I need to import NumPy into the Python environment. Okay, now I will just open my Anaconda browser also over here so that we can interactively work in Python programming also. So just type here Anaconda. So it will give me Anaconda Navigator. Just click it. And then again the same old thing which we did yesterday. You have to launch a Jupyter notebook. That is a one interface which help us to write the code over there and execute it also. So that is very simple. So once this it is opening here and Navigator, it has n number of functionalities like Jupyter Lab, Spider, and even you can see here I have the interface for R also. The people who are interested in learning R language, we can directly install here and we can execute R code from here itself. Okay. So but here currently we are in the Python. So I will launch this Jupyter notebook. So once this notebook is loaded, I will create one blank node Python sheet for me. Okay, a blank Python sheet. How to create that one? Yesterday also I told you there are so many folders. These are specific to the user. Whichever login you have done, accordingly these folders are visible to you. Now here yesterday we had created one folder called geoprocessing. Just click it. So this was the work we had done yesterday. Untitled was there. So we can just open the yesterday's work. So we can see it here. All the work which we did yesterday, it is directly saved over here. So what I will do, I will try to rename it. Okay, we can just click that untitled and rename it. It was INTRO, introduction, DUCTION, introduction, and then I can rename it. Okay, so my first Jupyter notebook is saved. Now I want another one. Okay, so I can file, I will go new notebook, Python 3. So it will create one more notebook for me. I can just change the name of this notebook to NumPy and MatplotLib. MatplotLib. Okay. Now these are the two concepts which we are going to learn today's class. So I am creating one notebook for it. Now here all the NumPy and Matplot related activities will be performing here. The first is NumPy is not a native Python library. It is external library. So I need to import it here. IMPORT import NUMPY. I can give one alias to it also because NumPy is a bigger name. So I can give one small name to it like NumPy as NP. Like yesterday OGR we were saying na, OGR.open. So instead of writing numpy.open, what I will use now np.open. So np is becoming an alias for me. So that we can do. So let us try to run this code, whether to check whether numpy is installed in my computer or not in this Python environment. Run it. So it says there is no error is there. So it means numpy is installed in my Python environment with all the dependencies. If you are not able to find it, if some error comes, then what to do? It was as simple. You just go here again, say a Anaconda prompt. If you don't find NumPy in your Python environment, Anaconda notebook, just go to this Anaconda prompt, and at this place, I will just change the settings also so that you can it is visible to all. 72. Okay, so this is the Anaconda prompt. Here you can type conda install numpy. This is the command. If you are finding some error, so this is one line you have to type there, conda install numpy, and it will install this numpy library into your Python environment along with all dependencies. And it will take the compatible numpy library also because they have different versions. So whichever version of Python is installed in your computer, the same it will fetch from internet and will install it. If you do it manually, then there are n number of problems will occur. Like it will ask which version of Python is installed in your computer and which NumPy module you want to install. So all those errors, they can be reduced if you are using this form of NumPy installation. Okay, directly conda install NumPy. So this is true for any kind of library which you want to install. Suppose you are interested in some more library like called MatplotLib. Simply type conda install MatplotLib. This MatplotLib along with this compatible version and dependencies, it will be installed and you can use it directly. Similarly, there are other like you will be using one very interesting library, that is GeoPanda. Okay, so that we will try to install it here like this only. Conda install GeoPanda. The next faculty he will be talking more on to that one. New modules are there, but here I am talking only for the NumPy, since NumPy is already installed there, so I need not to run this command. So we will reduce it. So this NumPy is already installed. Now we wanted to create one array out of it. So I was saying that NumPy is the module which help us to do array processing along with all the methods available with it. Let us create one simple array. I want the array of 10 numbers, 1 to 10, let us say. Just for use, I will say let us say A1, array 1 equal to NP dot, then you can press tab, let us say tab ARRAY, array. Okay, and then you bracket, here I want 10 numbers. So it will create me, it is as simple, it will create me an array of 10 numbers. If you see A1, you will say I have array 10 and print A1. Then I will see 10 number, only one it has created. So to have an array of 10 numbers, what I need to know, some error is there. Let us say I want the array from 2, 10. Okay, then if I run it, data type not understood. Okay, here it has the exact syntax of that is like this. If I say A1 over here, you will see the exact. So I will just see it here. Again, just go here. If I say import numpy as np, a equal to np dot array 1, 2, and 3. So it will create me this array. Again, I will go to this Anaconda prompt and let us try to do the same thing here. A equal to np dot array array, and then I have here in the common bracket like 1, 2, 3. Okay, so you just click it. So what it has done, it has created one array by the name A. Run 1, 2, 3. Okay, now if you see, you want to check whether this array, what is the type of this array? type type A. I can check whether it is an ND array or not. So it will say it is an ND array, NumPy ND array. So the data type of this value A is an NumPy array. Okay, so this is one array. So it has 3 elements, 1, 2, 3. Okay, now I want first the second element. How to get that element? We can have it like A, then you just give the bracket, because I told you arrays are starting from the 0 index. So if I say 2, so I will get the number 3, third number. Understood, no? So there are 3 elements are there, 0, 1, and 2. This is the 0th index, first index, second index. So I am typing second index, so it is giving the element number 3, third element. Again, we will go further into it. Let us say here. So this was as simple. So I can create one array of any n numbers, 2, 1, 2, 3, or it can be 100 numbers. We will see it, because most of the time we are not creating the array like this. Many times we get the arrays in the form of a file. Because I have a file, I will read that file, and from that file only I will create this array. Image is there. Image is nothing but a n-dimensional array. So how to do that one, we will see later on in that. Okay, but this is the basic type which will be used for all kind of array processing. Second, if we say now one of the properties of the arrays. So creating an array is as simple, np.array, you give all those numbers. Then this is an attribute, return the tuple consisting array dimensions. Dimension of the array, size of the array. Okay, how many rows and how many columns with that array. So this will create for me. If I say import numpy a.shape, it will tell me the type, the size of the array. Let us go again to this our slide here, to this browser over here. Let me create one 2-dimensional array. Okay, how to create that one? B equal to np dot array array. Okay, then this bracket here, then the first element 1, 2, 3. Then I can have one more dimension. This is the first dimension. Then I can have second dimension also here, 2, 3, 55, or let us say 20, 30, and 50. Here I will say 13, 12, or some elements are there. Okay, so this is my 2-dimensional array. If I say just run it here, so some error is there. So I will. What is that error? Data type not understood. So what is that? We have forgotten one bracket over here. So if you see, the relevance of this brackets is very important here. Now you have to make the array. You have to give one arrays first of all, one brackets. Then inside that bracket, you have to define the element. This is the first element, and then this is the second element. That way you have to define it. Okay, if I say run, now there is no error. Now I want print B. Let us say print B. What will be the value? It will give me there. This is one array with 2 rows and 3 columns. Let us check it with the help of that command, which was np.shape. Okay, b dot s shape. Okay, so if you click it here and then just run it, so it will give me. Okay, there is one not bracket is not required here because this is one method here, 2, 3. Okay, so there are some methods. If array, since array is one function, so these brackets are required. Now this shape is not a function, it is one property. Okay, it is one property of this array. So that's why I am not putting those bracket in front of it. So if I say b dot shape, it is saying me 2, 3. It has 2 rows and 3 columns. Like image का size मुझे निकालना है, then we will say b dot shape. Suppose b is one image, it will tell me what is the size of that image, and accordingly I can form my further operations by knowing these sizes of the matrix, how many rows it has, how many columns it has. So that way we can do it.
So you don't require to write print again and again.
No, not required here. But if you are writing the script, at that time you need to write that b dot shape also, because here so it is interactively I am checking it. Since Python is an interpreted language, so as and when it can be worked as a calculator also, we can say. You just type the command, run it, it will execute it. But if you want to write the entire script, at that time you have to write that print command also. If you are writing simply b dot shape, it won't do anything. So in the scripting, you have to write print command also. An important point to be noted over here, this one, because here so I am not writing any print command, but there you have to write it in the script. If you find some script from internet also, they will always write that print command in front of it. Directly they will not say. Then going further, if you say, so shape is one property of the array. It will give me the dimensions or the size of that array. Second, how to create empty arrays. Some blank arrays are also required sometimes. Why blank arrays are required, or blank array, or sometimes we will call them as a initialization variables, we will say. I want to initialize some variables. Initialization, those who are from the computer science background, so they know that there are some variables which are required for initializing something. Once it is initialized, then we can add something on top of it. So these are required at that time. So how to create an empty array? It is as simple like, and you can just type numpy.empty, and then this is the shape. You can write the size of that array, how much size array you want. So that can be created. Simply, if you want all zeros in that matrix, so directly you type np.zeros. So it will give a new array of specialized sizes filled with zeros. numpy.zeros and then size, whatever data type you want. So similarly, if you see one example for it, import numpy as np, x equal to np dot zeros. So it will create one matrix of zeros or one array of zeros. Let us take this one here, example here. If I say print, let us say print, here I want np. np is my alias for the numpy array. Dot zeros, zeros, and then bracket I want 5. What it does, let us say, try to run it. So it has created one dimensional array for me having 5 elements. 1, 2, 3, 4, 5 elements. Okay, so that way we can create it. Two I want, so that also can be created. So similarly, we will go to the further, because this will be requiring later on in our exercises. Similarly, I have numpy.ones also. If I want all ones there, so you can create it using this method called numpy.one. Now, again, there are some more properties of an array. Like I want to create an array of numbers from 100 to 200. एक एरेज बनाना है मुझे, और जिनके डिफरेंसेस हैं बीच में 2 या 10 का डिफरेंस बना के बनाना है. I want to create an array of numbers from 1 to 100 with a difference of 2 or with a difference of 5. How to create those arrays? So that can easily be created like this. numpy.arange is the command for it. Okay, this is not arrange, but this is a range. So here you give the start number and the stop, the last number, and how many steps you want. If you don't provide these steps and d type, it will take it as 1. Like if we say this example, np arrange 5, so it is taking 5 element, only it will create starting from 1. Okay, and step will be 1 only for it. Let us take this example also. Again, this arrange is very important here. I am creating one array, x equal to np dot arange. Just press tab, arange, and then here I say 5. So what it does? So it will create me one array. If you say 0, 1, 2, 3, 4, 5. Okay. Now the same method, if I am saying arange, I am giving 15 also. I am saying you create some numbers from 5 to 15 with a difference of 3. Okay, each number, so it will create me, if type here X and you see run here, then it will say 5, 8, 11 and 14. If you say first number is 5 plus 3, 8 plus 3, 11 plus 3, 14. So that way I can create this kind of arrays also. So this is one small example for it. Then here one more, this is one a range method. Okay, similarly I have line space. Now the another problem is like that, I want to create one array. First was I want to create an array from 5 to 20 with a difference of 2 numbers. Okay, now I want an array from 5 to 20. First number is 5, last is 20, and I want 100 numbers in between them. उनके बीच में 100 नंबर मुझे जनरेट करने हैं. So for that I have the method called lin space, len space. We will take one example for this also. This is also as simple here. Let's say y equal to np dot lin. We will take it len space here, as len space here. Then I want from 5, 15. Okay. Now here I want 100 numbers in between them. 100 is not the step, but they are counting equally spaced 100 numbers. What it does, let us say, and just see why. So it has created 100 numbers between 5 and 15, which are equally distanced. Same interval है दोनों numbers के बीच का. Okay. How to create that? So already some methods are there for creating this kind of number. Mathematics में मिल जाते हैं method हमको. But here it is already those functions are inbuilt into it. So I am getting these numbers from 5 to 100 numbers. Okay. Another example we will take. There is log space now. This function return an ND array object that contains the number that are evenly spaced on log scale. If I want the number to be in log scale, means उनका सबका log लेके number generate करना है. So for that I can use log space for creating some random numbers. There are numerous applications where this kind of numbers are required. We will go further into it. Further slide, if I say now, NumPy has 2 distinct data types. This is important slide over here. First, we have seen some ND array and then some method like set, arange, len space, and log also. Now here I have one more method called matrix. This is again array and matrix. These are the 2 different data types that are available with NumPy. Array, when to use array and when to use matrices. Array, they can be used for multi-dimensional problems like any kind of computations, image processing. These all arrays are used. But if you want to do some statistical analysis, okay, and in those cases where matrices are required, suppose I want to multiply 2 arrays, it should not multiply them as 1 to 1. It should do matrix multiplication. So for that I have different data type that is called matrix. Okay, so both they have their own usages. I can create an array also and I can create one matrix also. So both can be created with the help of NumPy. Then you have to see which application you want to apply for it. Image processing, go for arrays. And if you want to do something where you require inverse of a matrix, transpose of a matrix, yeah, linear equation solution you want to do, linear curve fitting, so all those things you should go for matrices. Now for this case studies, for this today's class, we will be discussing on matrices only. Arrays, further Dr. Prasoon Gupta will come, he will be discussing when he will be talking about image processing. So at that time he will tell all those things. Okay, so if we say this already we have discussed about it here. If you one example we will take it. This one important example here. I am creating one array. This is a 2-dimensional array. This is first row and this is the second row. And similarly, one matrix I am creating. This is the first row and this is the second row for it. Okay, so if I say A, it will create an array of 1, 2, 3, 4. If I do A into A, what it will do? It will multiply this 1 by 1, 2 by 2, 3 by 3 and 4 by 4. 1, 1, 2, 2 is 4 and 3, 3, 9, 4 and 4, 4, 16. But the same thing if you do with this M into M, it will do something else. this is what it is doing, the matrix multiplication. Let us take one example to it here. If I go here now again, let us create one array and one matrix. Okay, I will create one, let us say I will create A equal to np dot array, A-R-R-A-Y, np array, and here I am creating one matrix. My matrix is 3 by 3, 3 rows and 3 columns. Okay, so the first method is you have to put these square brackets. Now inside the square brackets, I will create 3 rows with 3 columns. How to create that one? Again, put one more square bracket. This is the first row. I will say 20 comma 23, let us say 4 2 comma 3 comma 4. This is my first row. Second row, again put one square bracket. Here I will say 4 comma 9 comma 16. This is the second row. I will create the third row now. Okay, third row is, let us say 8 comma 27 comma 64. This is the third row. Okay, so now let us create one matrix also. I will create the same thing with matrix m equal to, I will just copy it, the same thing as a matrix also. Now if you see the difference between them, now here I will have matrix, matrix, matrix. Now I have A an array and M one matrix. Okay, you just run it. So two things are created. Now let us check whether what type is there. Type A, if I say here again, I will say TYP, type M. You just check it, run it. So it is saying type M is A is array. Okay, type TYP, type A. Let us run it here. So it is an ND array. If I say type M, so you say, you check it, it is a matrix. So these two, there is a clear difference. In data type, they are different now. Now let us try to do one multiplication kind of thing. A into A. Multiply A by A. Okay, A into A. So what it should do? 4, 9, 16, 16, 81, 256, 64, 729 and 4096. If I do M into M, it is a different case now. Okay, what has happened over here? Here, while multiplying two arrays, A into A, multiply this array A by A itself. So what it will do? One by one, it will multiply them. It will say like 2, 3 and 4, 4, 9, 6, 8, 27, 64, multiply corresponding numbers. First 2 into 2, 3 with 3, 4 with 4, like that way. Okay, so it is like this. If I say it here, at the end I will go new slide. Here we will say one, I will try to create one, this A equal to one matrix is there. Matrix A equal to 1 comma 2 x small 3 I am taking 1 comma 2 comma 3. I hope you understand it. Then not comma. If I will create it here. Let us delete it. I hope it won't take much time. Just for the sake, 4 comma 3 comma 5. Let us take this one only. Now I have B. One more matrix is there called B. I will say one more matrix is there. Control C, Control V. I have another matrix called B. B. If I say here, let us say 2. Then here I have 5. Here I have 30. And here I have 59 or 9 something. 7, 6, something I am having. So if I am doing this A into B as array, so what it will do? It will multiply this A with A only. I will just make it further. Enhance it here again. Just for the explanation, I am just trying to do it here. If you see here, if you try to multiply these two matrices, what it will do? It will, if they are the arrays, it will multiply 1 by 2, 2 by 5, 3 by 30, 2 by 6, and 3 by 7, and 5 by 9. So this will be the array multiplication, means 1-to-1 multiplication it will do. But at the same time, if you do matrix multiplication, it will not do the same thing. It will do the mathematical operations of matrix, like 1 multiplied by 2, 2 multiplied by 6, and then 3 multiplied by, it will not do it because होगा ही नहीं है, because it is, these two are not compatible for matrix multiplication. So okay, so it will not do it. 3 by 3 though it will do it, but these two matrix multiplication it will not do. But array multiplication it will be doing 1:1, one multiplication by the other one. Okay, let us move further here. I will go. So that is one important thing with the matrices which we wanted to highlight over here. A into A means 1-to-1 multiplication. M into M means matrix multiplication. Okay. So if we move further, there is something called vector also. What is a vector now? It is a very simple thing. A standard vector is a matrix with one column only. It has only one column. So this is required in various kinds of linear algebra or the matrix multiplication kind or matrix operations. This vector is required. So a single dimensional or a single column vector is called a matrix is called a vector. Okay, it is as simple. You can create it like this: A V equal to matrix 5, 6. So it will create it. Similarly, if we do the multiplication that we have done in the previous slide, M is one matrix 1, 2, and 3, 4. Similarly, I have one vector V 5, 6. If I am doing the multiplication like simply M into V, what it will do? 1, 2, 3, 4, 5, 6. 1 into 5, 2 into 6. They will add it. 1 5 is 5, 2 6 is 12, plus 5 17, and then 3 5 is 15, 4 6 is 24, plus 15 39. Okay, so this is called the matrix multiplication. So it will do like that way only. Second, if you say transpose, this is very simple. Again, one method of matrix. So here you can simply create the transpose of this matrix by typing this point T. Okay, just type M dot T and it will create you the transpose of that matrix. 1, 2, 3, 4 is one matrix. 1, 2, 3, 4, then 1, 3, 2, 4. It will create it. All the rows will become columns and columns will become row. So no need of writing a separate code for it. Just type T. That NumPy will take care of it. And this is one method for it. Similarly, identity matrix. So I can create one identity matrix also by the name called identity. Directly write identity and your identity matrix will be created. This is also very much useful, required in various kinds of matrix operations. So if I say I2, so it will create me a 2 by 2 identity matrix with diagonal elements as 1. We will see where it is required. कहाँ पे इसकी जरूरत पड़ रही है, that we will try to understand later on. Okay. Similarly, if you see here I have one matrix called A, and then I have I into A. Okay, matrix multiplication. I into A is again A, and A into I is also A. So if you multiply identity matrix with A, or you multiply the matrix with A, you will get the same thing. Okay, it is a rule of mathematics or the matrix operations. Again, inverse, very complex operation in mathematics in your matrix algebra. You have to, first of all, you have to find out the disjoint. For the determinant you have to find, then some disjoints or adjoint matrix you have to find, then multiply them. So it's a very complex problem, but here it can be done simply by writing matrix dot I. It will create the inverse of that matrix for you. And where that will be useful, we will see it, where how to make use of, because we have an example for that also. Finding the inverse of a matrix is not very trivial. Well, not very easy. It can, but here using this NumPy, it becomes very easy. How? You just type A dot I and it will create you the inverse of that matrix. This is one matrix A 2 minus 5 minus 1 3, and I have this thing. Okay, it will create the inverse of that matrix. Where it is required, we will see one example for it. Okay, again, this is again one important example over here. like A into A inverse. If you multiply the matrix by the inverse of that matrix, you always get one identity matrix. Same is true with the reverse also. Multiply inverse of matrix with A and you get I. So all this we can do very simply with the help of this A dot I into I, and you are getting the same thing over there. Okay. If you see here, reverse transform now. This shows us if we have a transformation matrix, most of the time required in geoprocessing. There is one transformation matrix and I want to convert from one projection system to another projection system. So that becomes very useful when we are using this kind of operations over here. So which transforms a coordinate vector V to the vector W, then the reverse transformation from vector W to V is given by the inverse of that matrix. I have one transformation matrix or standard hoti hai, okay, which will convert from one projection system to another projection system. There are some set matrices are there. You take it, convert from one form to another form, and if you want the reverse, you just find the inverse of that transformation matrix and you will get the original values as such. So it is simple here, just running it, the two commands over here. If I now we will see one example for it, the same example for it here. I have one transformation matrix, this 2, 2 minus 5 minus 1, 3. So I have this W equal to AV. So V is your 1, 2. Now you want what are these values in another coordinate system, that is W, with the transformation matrix A. A is the transformation matrix for this converting from one projection to another projection. Okay, so just multiply them and you are getting it the same thing. If you do the reverse, this just find the inverse of A. Inverse of A is again A dot I. You multiply them by W and you will get the original values 1, 2. Again you are getting it. So it becomes simple over here. We will see one, 2 or 3 lines only how we solve this equation now. Now learning all these concepts, let us go to this one very basic equations that we have been learning since ages. बहुत बचपन से पढ़ रहे हैं इसको हम कि how to solve. I have 3 equations there and I have 3 unknowns also. इसका example एक हो सकता है. Let's take one example here. I want to find out the coordinates, how the GPS calculate the coordinates, how the GPS receiver calculate the coordinate of a point. Okay, how it calculates? It takes locations from 4 known satellites. 4 known satellites, it takes the signals. So it can calculate the distance from those 4 satellites, and based upon those 4 satellites and distance, speed of light is there, location of satellites are also known, and 4 unknowns are there, X, Y, Z, and one time factor is also there. Okay, that time correction values are clock corrections we can say to time factor only. So 4 unknowns are there and I have 4 satellites, I have 4 distances. So I have 4 equations. You can just solve it and you will get the values. We will take one example from here itself. Okay, so I have one equation 3x0 plus 1. We will just go to here directly. So I want to solve one linear equation. Okay, so we will just put some command for here. So we are writing one code for it. SOL. Just make it further. SOLVIN, solving LINER, linear equation. EQUATI, equation with 3 unknowns. 3 unknowns. 3 unknowns. Okay, I will try to make it as live as possible here. Unknowns. So I have first equation, like let us say it is 2x plus y plus 3z equal to 5. This is my first equation. Then I have the second equation, 4x plus 2y something plus z equal to 1. Then I have my third equation, because there are 3 unknowns, so 3 values are there. We can say it x plus y equal to 7. Now here z is 0. Okay, let us say that is 0 z, I can say it equal to 0. So this way I have 3 equations and 3 unknowns are there. how to find the values for it. So this becomes as simple like here. If you see here, I will create one matrix first of all with these values 2, 1, 3, 4, 2, 1, 1, 1, 0, and then I have one more matrix of x, y, and z. Only 3 coordinates are there. Okay, and then 5, 1, and 7. These are the 4 constants are there. Values are there. So it becomes. Let us create the first matrix for it. M equal to. It very simple. And np dot only 3 or 4 lines. I will get the solution for it. Np dot matrix 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 np dot m, if I say atrix matrix, then in the bracket I will write the first row. It will be like 2, 1, 3. Okay, the first equation. The second equation, second row, second equation 4, 2, 1. This is my second row. Okay, now I will create my third row also. That is third row is, what is the third row like? 1, 1, 0. Okay, so I have created the matrix of all the coefficients. Matrix is created. Now I have some variables also. Let us say variables v equal to, the variables are now np dot array, I'm sorry, matrix matris matrix here. Again, although this is not required to be created, but I will just, for the sake of purpose only, we are writing it here. This is the first is x. Okay, first element. Second element is y. Important point to be noted here that I am not writing all these in one bracket. I am creating separate brackets for each because I want 3 rows. X is first, second, and third, and then comma. I have the third one, z. So this variables are also created. Then the constants c equal to that I have one again np dot matrix 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 matrix, and then I will have it like here. The 3 values are, the first value is 5, first row. Second row is 1, second row is 1, and then I have the third row. Third row for third bracket now. Third row is 7. Okay, as simple now. Okay, so I have now converted the equation in the form of matrix. First equation means the first 3 things. This becomes my first row. This becomes my second row. This becomes my third row. 5, 1, and 7 constant for 3 rows. X and Y and X, Y, Z are the 3 variables. Now how to solve it? Solving is as simple like here. We can create it in only one line also. I will say V equal to, it will be like M inverse dot I into C. This is only line which will calculate me the matrix, the equations for this. Run. Some error it is giving. Z is not defined. Where is that Z? I will just put this as a comment here. Comment Z somewhere I have written. Okay. Run. Okay. So if you see it here, V, print V, print, print V, you just run it. So bracket is missing here. Again, you have to put the exact code you have to put. Run. So minus 7.4, 14.14, and 1.8. These are the 3 values of X, Y, and Z. How it is coming like this? Let us go to this matrix here. If you see, V equal to M inverse into C. Directly I am writing it. So only with the help of this one line, I am getting the solution for that equation. Okay. So you will see with the help of the slide, let us try to see it here. This is my first matrix of all the coefficients. These are the unknowns and these are the constants. So I can put all these things over here and multiply them and I will get the values. If you see it here, M inverse Y means once this matrix goes over here, it becomes the inverse. Or I will say M inverse into M and here M inverse. So M inverse into M becomes I, that is identity. You multiply by identity, again it will get the same thing, but here I will have M inverse Y. Y is the values which are having the constants. Okay, so as simple it is. One line I am getting the solution for those equations. Okay, it is as simple. So linear equations can be solved like this only. Now next is our one more example we will take, that is for the curve fitting. Now problem is that I have a set of values, x and y values, for let us say x and y value. It can be a value like rainfall and temperature. Two values are there for n number of locations. Now I want to find whether there is any relationship between them. If there is any relationship, how to convert that relationship into an equation so that some unknown values can also be calculated. Correct, na? Known observations are there. You create one equation out of it, the appropriate equation, and then you can find unknowns also. Not only the knowns, but unknown values can also be calculated. What is the equation between them? So with that, we will go further to it. This already we have seen it here. Least square fitting. It goes like this. Now, our square fitting, least square fitting can be a straight line like y equal to ax plus b, or it can be a quadratic polynomial also, y equal to ax plus bx plus c square. That depends how your data is following, what pattern data is following. If you just take all those observations, plot them. Once you plot them, then you will come to know what is the trend of this data. If it is following a straight line, you draw one straight line for it. That can be done with the help of this NumPy. Only one line is there for that. Okay. Similarly, if you see that your data is not following a linear trend, data is following a quadratic kind of thing. As a data plot ho gaya aapka x axis and y axis, you plot them and it is going like some curvilinear kind of thing it is giving. So that time you have to plot a quadratic polynomial, or sometimes the cubic polynomial also, or some higher order polynomials also can be created. So we have different methods for it. So how to do that one, we will see. If you see, suppose you want to fit a straight line. One example we are taking it from set of observations. I want to fit one straight line. So these are the known observations. Okay, so what I will do, y1 equal to a plus b1x. y1 is known to me, x is also known to me. y2 equal to a plus b x2. yn equal to a plus bx. Now my task is to find out the value of this a and b so that equation becomes generic. फिर वो किसी के लिए भी हो जाएगा. Correct ना? That way. So how to do that one? How to find out this a and b? So for that, again, through mathematics, it has been proved how to find out those values. So what I can do, these are the unknowns, m transpose into m transpose into y. Just this is your matrix. Now if you can create one matrix out of it here. If you able to see it here, y is y1, y2, y3, one matrix I have created. Similarly, for the other one, like x1, x2 and xn, for this also another matrix is there. So but since it is a linear equation or it is a straight line, so I am putting it here only 1, 1, 1. Suppose I have it is a quadratic equation like this 2, then I will have one more column of 1, 1, 1. Now since it is linear or the straight line, so I have only 1, 1, 1 and x1, x2, x3, and these a and b are the unknowns. Okay, these I need to find out. Y is known to me, x1s are not known to me. I need to find out this a and b only. So this can be done very easily with mathematics here. Y equals to m into v. So what we can do? Transpose both the sides. M transpose, here also m transpose into m. वो कैसे करते हैं mathematics में? So and then v remains over here only, and this m transpose into m goes here as an inverse like this. V remains there, m transpose into m goes as an inverse over there, and already here I was having m transpose. So this m transpose is already there. Done, है ना? It is like multiply both the side by m transpose, m transpose, and then you have to shift this m transpose into m to y, because y is known to you. A and B निकालना है मुझे. Okay, V is I have to find out. So I leave it here only and just I put it here, so it will go as an inverse over here. So you see it here, it goes full as an inverse. Already M transpose were there, and then multiply all these things and you will get those values. We will try to see that also. Okay, so these are our values 0, 1, or 1 3 2 4 3 0 1 1 3 2 4 3 4. Okay, so let us take the values like this. So I will go here. I will write one more code for it. Least square fitting now. Let us say LEAST, least, SQUAR, least square fitting, and to be more specific, it is straight line fit. Straight line I want to STRAI. It is straight line fit. Simple code we will try to write here. You all should be able to do these codes also yourself. You take some observations from your side and try to plot them using code. So once you are thorough with these kinds of code, then you can go for the advanced coding also. वो जो geoprocessing में करना है, that will be easy for you. But you have to practice with this only. Then you can go for there. Now observations OB. Let us say this hash sign is for the comment. Okay. OBSERVATION. Observations are like 1, 0. This first. I will take it same from here also, so that we can cross verify also. 0, 1, and then I have another value. How many values are there? Let us try to check. 1, 2, 3, 4 observations are there. 1, 3, 2, 4. Okay, 1, 3, and then I have 2, 4, and then the last observation I have is 3, 4. 3, 4. So these are the observations with me. Now I want to fit a equation into it so that others can also be find out. Now here it is, for x equal to 0, I have y1. For x equal to 1, I have y equal to 3. x2, y 4. x3, y is 4. Now similarly for other location I want it. So how to know that one? You have to fit some equations with it. Once you fit the equation, then only you can change those values. Unknown ko change kar dena and you will come to know the known value, change it and you will know the unknown values over there. So that once you know the equation for it, what is the trend it is following. So how to find out that one? So let us first create one variable x equal to np dot matrix. Now this I am doing it manually, but we can do all these things through programs also. Reading the file and then putting it into the matrix. Already I have some Excel file with me. You read that Excel file and convert them to matrix. Right now I am converting them manually over here. Matrix, then here I have first value x I am creating a 0, comma, second value is our 1, third value is our 2, 2, and then I have one more value called 3, but I will put this bracket also over there. So similarly I have y also, y equal to same thing. I will copy from here and then I will change those values. Control C, Control V. I am creating two values over here. This is now 1. Here I have 3. For this I have again 4. The last value is also again 4. Okay. So these two values are created here. Now I want to fit equation for it. So equation formula we are knowing it. M inverse, M transpose into M, then inverse, then again M transpose, then multiplied by that Y value. Okay. So I will create my M matrix first of all. Okay. So if you see this code over here, this algorithm, if you see it here, I need to create this M first of all. What is V? V are your values A, B, and C that you need to find out. M, but where is M will come from now? M is nothing but these X values. First column will be your ones and second column will be your values of X, 0, 1, 2, and 3. 0, 1, 2, and 3. So same way I will create it here. M equal to np dot mat matrix, matris matrix here, and then I need how many? 1, 2, 3, 4 I require. Okay. So I will create it like this. So the first row will be 1, 0 X value, and second will be again you have 1, 1, the second x value. Understood, no, this one? Are you following it, getting it? The first one, I have to create, if you see it over here, I have to create this M matrix to get that equation. So M, the first column will be your ones. You take it default value, constant value 1, and second will be all the x values. Okay, so the same thing I am doing it here also. These 1 and the x value. What is the first x value? 0. Second again 1. Second x value is also 1. Now the third one. Third one is again 1. First value is 1 and the second value is 2. Correct. And then comma here. The fourth one we will require it is 1, comma 3. So now I have created my M. M is created. Now let us try to create that Y also. Y is already there. Already we have created Y. 1, 3, 4, 4. Now this I have to calculate V, those A, B and C, and Mx plus C, okay, equal to M. Only thing, you have to convert your observation to matrix. Once it is created, then there is only one line of code which will convert it, which will give you the coefficients of that line. Let us say M dot, let us take one bracket here, M dot M into M dot T. What is T? Transpose. It will create the transpose. I want the inverse of this entire dot I. Okay, first is done. Then you have to multiply with this equation, this expression with again M dot of T. Correct? If you see it here, again M T inverse M of T, then Y also is there. The third column is your into Y. Your Y is calculated. Just run it here. Some error it is giving here. We will try to see what is that error. Singular matrix. We'll try to see it here. Some error it is done here. I think I have done some mistake there. Everything is fine here. Some what can be the mistake over here? NP. NP dot matrix. This is 0, 1, 2, 4. NP dot matrix. This is also done. NP matrix. 1, 0, 1, 1, 1, 2, 1, 3. Okay, 1, 2, 3, 4. 1, 2, 3, 4. And then M into M of transpose. This is done dot I into M of T dot T. Correct. This is also expression is done. Line error. What the error it is giving here? I will see at the end here. Line error. Singular matrix. Singular matrix. All are matrix only, no? A dot 0 dot 1 dot 2 dot 3. Any bracket or comma is I am putting somewhere mistake. 1 comma 0 comma 1 comma 1 comma 1 comma 2 1 comma 3. V equal to M into M dot T. I into M dot M into M dot T. This is fine, no? MT. Okay. First is MT. M dot T. Then it is M. Both is difference is there. Okay. M dot T, transpose of M into M. It will give, because this is not a problem here. M dot T, transpose of, because M dot T is not equal to T dot M. Oh, sorry, the other one. M dot of transpose of that matrix. They are not compatible. You know, matrix multiplication identity is compatible, but this is not compatible. Now, if you see the value of V, print V. So if I see V, then I just run it. Values are 1.5 and Y. So your equation becomes like this. Y equal to 1.5 plus is 1 x. This is your equation now. Okay, this is A, 1.5 is A and 1 is your B. So Y equal to AX plus B. Or A plus BX, sorry, A plus BX actually. So first is your the constant, and then intercept we can say sometimes we'll call it as, and second is the coefficient of the X. Okay, so this is your equation. Now I want to plot it. Let us go directly for the plotting also. How to plot it? So we have got the coefficients. Let us plotting. I require MatplotLib. Now I want to draw it and plot it equations. So I have got it. So for plotting the equations, I will say IMPOORT import.
The output is 1.5 and 1.
Yeah, this is the output. 1 point it is rating 1.0 only actually. This one only. and 1.5 is the 1.5 only. Okay, so import. Now for MATLAB, I have PyLab. Import, I will say from PyLab, IMPORT, import star. So for plotting, we have one separate library called MatPlotlib. How to import MatPlotlib into my Python module is import from PyLab import star. This is also one method. Okay, I can import all the modules of PyLab into my current working environment here. So plotting is as simple. If I say PLOT, 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 if you write it here, x comma y, simply you write it here. X is some value you are having over here. Some values are there in x and some values are in y also. Just want to plot it. You just write plot and just run it. It will do plot and then SHOW. So if you see, run it and you will show the plot is there. Okay, where is that plot? So why not displayed? Plot x comma y. It should come, no? That value. Check it here. Why that has not come? Plot x comma y from PyLab import. PyLab is working or not? Let us check first of all PyLab. From PyLab IMPORT import star. Okay, from PyLab import star, run. That is working fine. Then I have one command called plot bracket x comma y comma red color. I want red. Okay, something with the red color. Then it should plot it. Okay, some error maybe there at that time. So it has plotted that line. These are x and y values. Okay, and I want them as O object. So it will create me those as points. 4 points were there. I will just reduce the screen size here like this. Okay, so if you see,
Understood by
this
language.
Yeah.
We have written R.
R is red, O for circle, O or something, it will plot it. There are some S you write, square it will print. Rhombus, R you will type. So that way it has, there are different methods for it, for plotting these kind of things. It can be blue color also. You write it here blue, it will plot it with the color of blue. So these are your X and Y plots. This is the blue plot. Now we had plotted our, we have created one line also. We want to plot that line also now. Okay, on top of these were the X and Y and they are following this pattern. So I want to plot one straight line over here. From where is that straight line? This is our straight line, 1.5 and 1. This was our straight line. Now I want to plot this straight line on top of this graph. How to plot that graph? Okay, so we will see one small for that also here. I will write the entire code from starting. From PyLab IMPO. Already it is imported, but I am writing it again. PyLab import star plot plot. I had x comma y comma R and O, or O I want it. Okay, so this is the first one, and then second I want those equations. Okay, for that equations, what I will do, once it is plotted, what we can do here, I will just change those values. X equal to np dot arange range. A range, I am creating some random values. Okay, so random values will be like from 1 comma 15. One example I will take it directly from here. Minus 1 comma 5. Okay, it will be some values minus 1 comma 5. What are these values now? If you see it here, for x and y, I have, for this x this is the y, for this x this is the y, for this 2 I have y equal to 4. Now I have many x. What will be the y for them? What are those x? So I am creating minus 1 to 5. There are some range of x values. Minus 1, minus 1, 0, 1, 2, 3, 4. For all I want now y. So what I will do here, y equal to 1.5, okay, plus x. This is okay, na? This was our equation only. 1.5 plus x. So now I will plot them. Plot. Plot. Understood, no? This thing. Plot again I want x comma y comma b and dash I want. Okay, let us try to run it here. So this is my straight line. Understood? You know, from -1 to, if you see it here now, x run, x is -1 0 1 2 3 4. Earlier this x was these values 0 1 2 and 3, but now I have many values for them. Let us increase it. It can be like 50 also, 15 also. Again it will create it. So if you increase your, it will in the larger scale, it will come and it's saying that all are fitting into this line only. Okay, so that way we can plot these things over here. Now we will take one small example here. Last here, one example, it like reading one file from, reading the data values from the file and then plotting them. One small example, because this, so what we have done it, we have already taken some values from somewhere and we are plotting it. Not plot, but manually we have typed those values. Now real life example, if you say it, I have one data set here. If you see it here, data, I will share you with this data set also. We can share it here. So I have one data set, Control C. I will just copy it here outside, paste. So I will rename it my data, MY DATA, my data 01. Okay, dot txt. We will see what is this data. I will take two data sets. Okay, open here. Now copy it again here. I will put it here, right click, paste, rename my data, MYDATA 022.txt. Okay, now what is the data set? Let us see the data set. Double click it. You will see there are some values, X values and Y values. To be more specific, these are the wavelengths and these are the reflectance of a particular grass. Same way I have, this is the wavelength of one graph and these are the reflectance of that graph. So I want to plot these things on my, using this MatPlotLib. How to do that one? So we will see it here. One example we will write it. First of all, let us say G1, the first grass one, or the D1 we will say, data one. G1 I will say G1 equal to np dot load. This is one method here, load txt. Load txt. Txt file is there, and then bracket. Yesterday I told you, now I require the entire file path here. If you see it here, right click, open file location. This is the path. Copy this path, Control C here, and then V. But it has to be within the strings. Important thing was that since I am using this backslash, so I have to use one small character called R over here. So it will consider them as a regular expression. Now here I will put here one backslash, name of that file. That was my data 01.txt. Okay. So this is G1 grass. And then I will take G2 also. G2 equal to the same thing here again. I will just copy it instead of writing it. Control C and then Control V over here. This file name is 202. Okay. So I have now two data sets. You just run it here. Directly you can check it. So if you say G1, print it, run. So it will show all those values. It has created one array out of it. Okay. Now we want to plot them. So plotting is as simple. If you see here, plot plot. G1 I want to plot. G1, comma, no. It is not like this. I have two values over here. This is the X values and these are the Y values. Our plot command was like X and Y. Where are those X and Y? Automatically it will not take. I have to slice them. I have to take them from those file to separate. So, okay. So G1 underscore I will say wavelength equal to one new variable I am creating, X variable we can say. That is X axis and Y axis. X axis I am calling wavelength. Y axis I will call as reflectance. So that's why I have written G1 underscore Y. So equal to I have G1 is my data set, which we have shared over here, G1, and then I can slice it like this. I want all the rows of first column. First column के सारे rows चाहिए मुझे. It has two rows. How many rows? Two columns it has. First column, second column, and it has many rows. Many rows are there. So I want all these rows in one, and the second one in the other one. So I will how to take it out now. So all rows means you just put one colon, all the rows, comma, 0. Because indexing start from 0. I told you, first column is not 1, that is a 0. So this is there, first it is there. Then I want G1 underscore R, reflectance also. This will be G1, then colon means all. You have to put one comma over here, then first column. Okay, done. So I have G1 W and G1 R also. If you say plot, now you say here G1 underscore W, comma, G1 underscore R, underscore R, and then comma I have which color I want. Let us say I want to plot them with green color. Green color will not be visible, black color. Okay, or let us make it red only. Then you just run this command, so it is plotting that grass for you. All these are the wavelengths, and these are your reflectances. Now I have two graphs, other one is also there. I want to plot that also. So for that also it is very simple over here in Python. You just copy it here, Control C, Control V. Now this is G2, second grass, second value, G1 and G2, and it is as simple, comma, you put those values also over here. The same thing which you have put it here, the same thing, copy and then just paste it here and then put them with blue color. Just run it. You have, okay, it will be G2, done. G2, and this will be also G2, and if you run it, so some error is there, I think. Okay, G2, G1W, comma R, G2 underscore.
So it must be G2 in G2 underscore W equal.
Okay, here also it is G2. Copying, pasting, some problems it will create. So we have to be careful while using them. Okay, run it. Then I have both the graphs here. Okay, in one plot itself. So I can compare now which grass has more reflectance. This red one, it has more reflectance. Now I want some axis, y axis, title. They are also very simple here. You just say XLABEL, X label equal to, you say wavelength, WAVELENGTH, wavelengths, wavelengths, and similarly I have Y label also, YLABEL equal to reflectance, REFLECTANCE, reflectance. If I will say RE, reflectances, okay, and then wavelength and wavelengths. Okay, you should just run it. So you have it here, X label equal to wavelength and Y label equal to this. Okay, I will just comment it here and just try to run this code here. So this is our reflectance curve, X-axis and Y-axis. So with this, I will try to close today's class. Okay, so thank you very much. Any questions from your side then?